This is our third video in working with polynomial functions. In this particular example, we will solve a polynomial equation that is not factorable with the usual methods that we know. To solve equations that are of higher degree and are not easily factored, we must find the zeros of the polynomial on the left side. Rational zeros are the easier to evaluate, so I'm going to use the rational zero theorem that says that I need factors of the constant term, which is negative 15, over factors of the leading coefficient, which is 1. So these fractions, these rational zeros, possible rational zeros, are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. And I can plug those into my calculator and check if they give me 0. After checking the possible rational zeros, I see that negative 1 and 3 are zeros. So I'm going to perform synthetic division. I'm going to write negative 1, and next to it on the top row I will write the coefficients of the polynomial. 1, 0, because there is no x to the third, negative 2, negative 16, and negative 15. And I will perform synthetic division, drop the 1, multiply, add, multiply, add, multiply, add, multiply, and get remainder 0. This is to verify that negative 1 is indeed a 0. Continue with 3 and perform a second synthetic division. Make sure again that the remainder is 0, so drop the 1, multiply, add, multiply, add, multiply, and yes, indeed, the remainder is 0. The trinomial quotient is 1x squared plus 2x plus 5, and I will find its zeros using the quadratic formula. Negative b, which is negative 2, plus or minus the square root of b squared minus 4ac divided by 2a. This is negative 2 plus or minus the square root of negative 16 divided by 2, which is negative 2 plus or minus 4i divided by 2. And if I simplify everything in the numerator by 2, negative 1 plus or minus 2i. Therefore, the solution set for this polynomial is negative 1, 3, negative 1 minus 2i, and negative 1 plus 2i. It was a fourth degree polynomial, and I found 4 real and complex solutions.